Now, before we start with the actual EJBCA deployment with Helm chart, let's look into the values we are going to use to customize it. Just remember that there's a lot of values, but you can always refer to the documentation, or you can just grab the values.yaml file, which has a lot of comments with use cases and examples so that you can always grab it based on the version you might be using and find out which properties are in there and how to use those. And for this exercise, let's just look into the values we are being using. First thing, you can see we are using replica count 2 because of course we just want 2 replicas. In the EJBCA block, the EJBCA is being customized with the most basic things. For an example, the database credentials. We are enabling audit log and setting the log level to debug so that during the first installation maybe something can go wrong. You guys can ask help with the debug logs to us for better response. And then finally we are coming to the HSM integration, which looks daunting as of this moment, but we are working hard to improve it and make it much more convenient. But you can grab most of this snippet from our documentation page. Now in the init container, we are adding the soft HSM container so that it can interface with soft HSM, same as in the sidecar. We have created this PVC to store or persist our key data, which is in the tokens we are mounting. We are adding the same thing in the volumes and the volume mounts because that's the way Kubernetes kind of expects it. We have provided this script in these volumes so that EJBCA can run this script to actually create those keys. And finally the database protection to enable signed audit log. After this we come to some miscellaneous properties. For an example, security with file system groups. We limit the resources to only 1 GB of memory. Feel free to play around with auto scaling as long as you have an actual cluster or you have already matrix server properly configured in that cluster. And you can also configure this whole thing with CPU along with memory or just with CPU too. EJBCA supports both kind of resource limitation and auto scaling. So feel free to give it a shot. And then finally the sidecar block for Nginx. You can similarly do this thing with HTTP D2. We enable it and we start with a self-signed certificate so that all the communications are at least over some TLS. Now please note that over here that we have to use a self-signed certificate because we have not even created a CA. After the CA has been created, we are going to create a server certificate to actually properly secure it. We enable load balancer so that cluster external access is also enabled. And then finally we enable sticky session based client IP based sticky session for our UI access. Please note that all other EJBCA services, for an example REST API, SOAP or protocols like ACME, CMP, EST, all these things are completely load balanced right out of the bat just for the UI. So when you access admin web or RA web, then you need to use this service. Note that in this case 2 IP address will be given to us. One is load balanced, another one with sticky session. So for the UI we are going to use the sticky session. So finally we are going to deploy EJBCA in this video. I have already set up a file with similar content, so I can just go ahead with the deployment. Please note I am using a file system based chart, but please use the Keyfactor repository link for this. So it's deployed. So let's see what are the things deployed. It will take around 2 minutes for the EJBCA cluster to be spun up. You can see there are 3 sidecars, one for EJBCA itself, another is for HSM, another is for the Nginx. And it's also noticeable that it is spinning up these pods in sequence. I mean, not parallel pod management is not enabled. That is because the first pod will take care of the database table creation or the index creation. And when you upgrade EJBCA, this first pod once more will take care of some database upgrade if necessary. Then we come to the services created. So we can see two load balancer IP as expected. One of them is load balanced. Another one is with sticky session for UI access. And then we come to the software system related PVC. We can see it is bound. Keep in mind that we are using read write many, because if you are like deploying in actual cluster, the EJBCs might be deployed in two different nodes. But once again, the write operation only happens with this fast pod. So that's about it. So let's wait a little bit and let's see. So it should take around 2 minutes. Okay, now everything has been spun up. So let's continue into another video.